Hey everyone, so in this video we're going to be talking about systems of equations. So a system of equation is just a set of two or more equations with two or more variables, right? So in this lesson we're going to be just talking about two variables and two equations. But it could be three variables and three equations. The number of equations and variables doesn't even necessarily need to match. For this class, they always are going to match. It's either going to be 2 and 2 or 3 and 3. But for now, we're just focusing on 2 and 2. All right. So it looks like this. All right. Two equations, two variables. Now, a solution to one of these is an ordered pair x and y that satisfies both equations. Alright, so normally a solution to an equation, usually it just has x in it, so usually it's just the x that satisfies that equation. It's the x that makes both sides equal. Now that there's x and y, and there's two equations, we need both variables, and it needs to make both equations equal on both sides. Alright, so for part A, let's look at -7, -2, and see if it's an equation. See if it's a solution. Alright, so -7, -2, this is our x and our y, and we're just going to start plugging into both of these equations. So I'm going to make the top equation blue, I'm going to make the bottom equation green, just so you can see when I'm doing something to one or the other. So if we plug it into the top equation, we do 2 times x, which is -7, plus 5 times y, which is -2, equals -24. We can go ahead and multiply. So this will be -14 plus -10 equals -24. Which is -24 equals -24. That one works, so it satisfies the first equation. We can't stop there though, because remember it has to satisfy both, so we have to check both. So let's plug it into the second one. So we got 3 times -7 minus 5 times -2 equals +14. So this will be -21 plus 10 equals 14. If we add those up, we get -11 equals 14. So this one doesn't work. Right? So if even one of these two does not work, that means no, it's not a solution. Alright, let's try part B. So -2, -4. Remember, this is our x and our y. So if we start plugging it in, we're going to get 2 times -2 plus 5 times -4 equals -24. So we're going to get -4 plus -20 equals -24, or -24 equals -24. First one works. Alright, let's check the second one. So for the second one, we have 3 times -2 minus 5 times -4 equals 14. Multiply, so -6 plus 20 equals 14, which gives us 14 equals 14. Alright, so in this case, both of them worked. So, yes, -2, -4 is the solution to this system. Now, systems don't necessarily only have one solution, right? Just like whenever we're doing normal equations, and we always said that it could either have a solution, a single one, or it could have no solution, or the solution could be all real numbers because any number would work. There's something similar with systems. Right? So we're going to look at 3 different methods for solving systems. First one's going to be graphing, and first off I'm going to explain those 3 different options for what your solutions can be. Alright, so your first one. The first one is whenever you graph it, and I'll explain later what it means for whenever we're not graphing it, whenever we're using the different methods. But for graphing, your first option is you could have 2 lines that intersect at one point. Right? Wherever these 2 lines intersect, that is your solution. So you can have one solution, x comma y. Right? Now, we also call this a independent and consistent system. So just read the left and top. It'll tell you what kind of system it is. All right? So this one's consistent and independent. All right, next up, we have an inconsistent system. So for an inconsistent system, the lines are parallel. They never actually touch anywhere. Remember, I said that the solution to the system was going to be where the lines touch. Well, if they never ever touch, then that means there is no solution. Right? And we call this one inconsistent. All right, the third option. The third option, and it's really hard to see on here, but here's what happened. We drew our first line right here, and whenever we graphed our second line, it actually ended up right on top of our first line. They're the exact same line. So in this case, remember, our solution is wherever the 2 lines touch, right? Well, if they're the exact same line, they touch everywhere on that line. All right, so our answer, it's not quite all real numbers, because remember, this over here or this over here, those aren't solutions because the line isn't over there. So it's not all numbers, but it's any number on this line. Any point that you can see on there is a solution. So we say it has infinitely many solutions. Right? And we call this one dependent. All right, so that's just the 3 different types. So let's go ahead and get started graphing some of these. All right, so let's look at our first example. X plus y equals -1 and y equals 2x minus 7. All right, so we're going to graph both of these just so we can kind of color code it. I'm going to make the top one blue, the bottom one green. Now, you can graph these however you want. So you can use y equals mx plus b, use the slope and intercept to graph it. You can use the x and y intercepts if that's easier for you. You can just plot a bunch of points that you know are on the line and draw the line through it. However you want to graph it is perfectly fine. for all of these examples, I'm pretty much going to be using y equals mx plus b. But again, do whatever's easiest for you to graph them. So let's start with, already messing up my color coding. There we go. X plus y equals -1. Alright, first thing we need to do is we need to just subtract x from both sides because y needs to be alone for this to work. So y equals -x minus 1. So we know our slope is -1 over 1. We know our y-intercept is 0, -1. So we start with our y-intercept, 0, -1. Then we go down 1, right 1, down 1, right 1. Over and over, and that gives us the points for our line. You can go the other way as well. Okay. Then we're just going to draw the line through it, and I highly recommend using a ruler and being as precise as possible for these, because remember, we need to tell exactly where the lines cross. So if your line is a little bit curved because you didn't use a ruler, it could end up crossing at a different point. So try to be really precise on these. Alright, so we got that first line drawn. So the second one is already in y equals mx plus b form, so we can just look for our slope, in this case 2 over 1, and our y-intercept, which in this case is 0, -7. Remember, it's just the number by x is your m, your slope, last number is your y-intercept. So now we're going to do the same thing. We're going to start down here at -7. We're going to go up 2 over 1, up 2 over 1, over and over, and then we're going to draw the line through it. Alright, the hard part is done. So once we're here, all we have to do is look at where they intersect. Alright, so in this case, they intersect at 2, -3. And that's our answer. Alright. Now, to state whether the system is consistent, inconsistent, dependent, and or independent, remember, this is one single solution, so it is consistent and independent. Alright, let's look at the second one now. So second one, we're going to do the exact same thing. Let's say the top one's blue again, bottom one's green. So for our top one, it's already in y equals mx plus b form. So our m is -1 over 1. Our y-intercept is going to be 0, 4. So we start up at 4. Then we go down 1 over 1, over and over, getting our line. Then we can just draw our line through these points. So that's our first one done. Now we go for our second one. So 2x plus 2y equals 0. In this case, it's not quite solved for y yet. So we can start off by just subtracting 2x from both sides. We get 2y equals -2x. And then we can just divide both sides by 2. So we get y equals negative x. So our slope is going to be negative 1 over 1. And what about our y-intercept? So there's nothing over here for the y-intercept. So that just means it's 0, 0. So we start at the origin, then go down 1, right 1, over and over again, and draw our line through it. And there's our second line. Alright, so time to look for our answer. So where do these two touch? Well, they don't. They're perfectly parallel. Right? And the way to make sure that they really don't touch and that you're not just accidentally not drawing enough of the lines that they touch eventually is to look at the slopes. If the slopes are the exact same, that means it's not just going to have one solution. It's either going to have no solution or infinitely many solutions. All right, so that's kind of your tip that it's going to be one of those two special ones. But in this case, since they never ever touch, it is going to be no solution. And if it's no solution, we call this inconsistent. All right, let's look at one last one for graphing. So again, top one's going to be blue, bottom one's going to be green. Top one's already solved for y, so our slope is 1/2. Our y-intercept is 0, 1. All right, so it means we're going to start up 1. And then for our slope, it means we're going to go up 1, right 2, up 1, right 2, over and over. And again, you can always go the other way by just reversing those directions. So down 1, left 2. All right, and then we draw the line through these. All right, there we go. Now we can go on to the second one. So 2y minus x equals 2. All right, we can move x to the other side by just adding x. So we get 2y equals x plus 2. Then we need to divide both sides by 2. So we're going to get y equals 1/2 x plus 1. All right, now it should be looking kind of familiar, but let's kind of go through with it. Our slope would be 1/2. Our y-intercept would be 0, 1. So we start up 1. Then it's up 1 over 2, up 1 over 2. All right, I know it's kind of hard to see, but all of our points are on that same exact line. All right, so if we draw this, I'm going to make it a little bit bigger just so you can see it. It's overlapping with the blue line. All right, they're the same exact line. So, which one is this one? Where do they touch? Well, they touch absolutely everywhere on the line because they're exactly the same. They're overlapping. So, that means our answer is going to be infinitely many solutions. And we say this one is dependent. Oops. Alright, so that's kind of one of each case. So remember, it's just graphing two lines, seeing where they touch, and writing that answer. Alright, this video is getting a little bit long now, so next video we're going to start talking about the other two methods for solving these. You don't necessarily have to graph all of these. There are two other methods that you can use to solve systems. So right about now you should see a little card pop up that'll take you to the second part of this video, so go ahead and click that, head over there, and continue on. All right, I will see you there.